Welcome back to Arxflix. Today, we're diving into the fascinating advancements in the paper titled Adding NVMe SSDs to Enable and Accelerate 10B Model Fine-Tuning on a Single GPU. This paper introduces FIU, a low-cost training framework designed to facilitate the fine-tuning of large models on consumer GPUs by leveraging NVMe SSDs. Large language models, LLMs, have captured considerable attention, growing in size from 1.5 billion parameters in GPT to 540 billion parameters in PaLM. However, even the most powerful GPUs, like the NVIDIA 10 with 80 GB of memory, are unable to handle models of this magnitude due to the extensive memory required for model parameters and optimizer states. Traditionally, aggregating the memory of multiple GPUs is one solution, but it's prohibitively expensive. FIU addresses this issue by enabling the fine-tuning of enormous models on a single lower-end GPU, using efficient SSD-CPU communication. Let's break down the three main innovations of FIU. First, FIU incorporates a synchronous out-of-core CPU optimizer that overlaps with backward propagation. This ensures the GPU isn't idle, while the CPU updates the optimizer states, maximizing GPU utilization without compromising the training convergence rate. The second innovation is a fully pipelined activation swapping mechanism between GPU, CPU, and SSD. This allows for efficient data swapping and enables the fine-tuning of significantly larger models by utilizing SSD capacity instead of being limited by GPU or CPU memory sizes. Here's an overview of FIU's system architecture. It illustrates the pipelined communication strategy that overlaps computation and data transfer across GPU, CPU, and SSD, solving zero-infinity's serial execution problem. Lastly, FIU presents an automatic activation swapping management mechanism. This feature optimally determines the amount of activation data to swap, effectively minimizing epoch time. The impact of this is clear when comparing throughput. FIU outperforms zero-infinity, achieving up to 3.47x TFLOPS when fine-tuning GPT-3 on an RTX 4090. FIU's innovations have been thoroughly validated through various experiments. When fine-tuning a GPT-3 175P model, FIU demonstrated 87 TFLOPS on an RTX 4090 and 170 TFLOPS on an A1080 GB, while zero-infinity and Colossal AI failed under the same conditions. This figure shows the GPU throughput of FIU compared to other baselines. Remarkably, FIU not only supports fine-tuning larger models, but does so with significantly better performance. To wrap it up, FIU stands out by enabling the fine-tuning of extremely large-scale models on commodity hardware. It effectively uses SSDs for activation swapping and introduces a highly efficient overlapping strategy to achieve this. Thanks for joining us to explore this cutting-edge research. If you enjoyed the video, be sure to like, subscribe, and hit the bell for more insightful summaries on Arxflix. See you next time! Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.